Hi all, I am Prijimo Bibi, Assistant Professor from Basic Sciences and Humanities Department, Christ College of Engineering, Irinalakuda. And I will be discussing some previous year question paper solutions for KEAM 2020 exam on the topic integration. Before I start with solving some problems on integration, let me introduce you to some few concepts on integration. Integration is actually a process of finding a function g of x, the derivative of which will give you the function f of x. It is a way of adding slices to find the whole. It is widely used in finding the areas or volumes under the curve. Now, how is this done? It is actually done with the help of slices. Now, take a look in this figure. In this figure, I want to find the area under the curve f of x, and I have considered as many as rectangles of same width delta x, and upon adding the areas of all these rectangles, I have approximated the area under the curve f of x with the sum of all the areas of the rectangle. Now, you may notice that we have some error because we can have some error here in this part as well as in this part. So, I don't think that the answer will be that accurate. Now, consider this figure. In this figure, what I have done is I have tried to minimize the value of delta x, that is the width, to be very small. Now, you may notice that we have minimized the errors as well, and the answer keeps on getting better. If you are approximating delta x to almost 0, then what happens? Now you can consider the third figure. The area is of approximately equal to the area under the curve f of x. Now we are getting the true answer. But the process of adding all the areas of the rectangle and then approximating it with the area under the curve f of x seems to not to be a practical way of solving the problems, and there is a shortcut method of finding an integral, which is nothing but finding the reverse of a derivative. Now here are some integration standard formula. You can pause the video whenever you like and then go through all the formulas. Now let us begin solving some few questions which was occurred in previous year question papers. Question 1. Evaluate integral minus 1 to 1 maximum of x cube dx. These are your options: 3 by 4, 1 by 4, 1 by 2, 1 and 0. Now, consider the given integral. In this given integral, you may notice that we have the lower limit as minus 1 and the upper limit as plus 1. So, our maximum function lies within the interval minus 1 and plus 1, and it is going to make a lot of changes between the negative interval as well as a positive interval. So, what we do is we try to split the integration into two. That is, one from minus 1 to 0, the other from 0 to 1. Now, what happens in this interval 0 to 1? In this interval 0 to 1, we find countably many rational numbers, and among all those rational numbers, if you are considering, x will be the biggest among all compared to x cube. Now, what happens in this interval minus 1, 0? Here also in minus 1, 0, you may find countably many rational numbers. Among all those rational numbers, if you are seeing, x cube will be the greater than x. Now, if you are not satisfied with this, let me help you with an example. So, here we have an example: minus 1 by 8 is greater than minus 1 by 2, whereas 1 by 2 is greater than 1 by 8. Now, minus 1 by 8 is nothing but minus 1 by 2 whole cube. And what is 1 by 8? It is 1 by 2 whole cube. So, from this example, now you may get an idea what I was elaborating in my previous step. Now, once you understood the maximum function, you can substitute alongside all the intervals and then integrate. What is the integration of x raised to n? X raised to n plus 1 by n plus 1, provided n is not equal to minus 1. Now, what is the integration of x cube? X cube integration will be x raised to 4 by 4 and then apply the limit minus 1 to 0. What is the integration of x? X square by 2, apply the limit 0 to 1. So, upon finding the integration, substitute the limit. How are you going to substitute the limit? Upper limit minus lower limit. See, here I have substituted. Upper limit is 0 raised to 4 minus, what is the lower limit? Lower limit is minus 1 the whole raised to 4 by 4 plus. Now substitute the limits for the second term. 1 square by 2 minus 0 square by 2. Now you can simplify this further. After simplifying, and then you get your answer as 1 by 4. So that was your answer. Now let us move on to the next question. Evaluate this integral. So these are your options. Now what we can do is, we can call the given integration as I or equation 1. Now you can solve this question by comparing the numerator and denominator. In the denominator, if you may observe, it is x plus 1. So what you can do is, you can simplify the numerator by adding and subtracting 1. So after adding and subtracting 1, you may notice we have x plus 1 as a common term as compared to the denominator. So what we can do is, we can split the integration into two terms, and then if you may notice, since we have common terms, we will cancel those common terms, and then we can open the brackets. Now what we are going to do is, we are going to apply integration by parts to each of these integrations. So here we have first one where we can apply integration by parts, and also the second one where we can apply integration by parts. But now I am not going to apply integration by parts for this second term. I will apply integration by parts for the second term later. Okay. Now only for the first term I am going to apply. Now what is the rule? Integral of u v dx equal to u into integral v dx minus integral du by dx integral v dx dx. Now try to remember this formula. And what does the rule say? Ilate. Ilate means I stands for inverse, L for logarithmic, A for algebraic, T for trigonometric, and E for exponential. Now in our first integration, since we have exponential term, we can consider that as the exponential comes at the end of the rule. So we can consider that as a second function v. So the remaining term, that is 1 by x plus 1, will be the function u. Now after applying in the integration formula, you will get an expression like this. Now here in this term, you can apply quotient rule, or else what I am going to do is, I am going to bring the x plus 1 in the denominator to the numerator. So it will become x plus 1 the whole raised to minus 1. Now what is the differentiation of x raised to n? N into x raised to n minus 1. Now what will be the differentiation of this function x plus 1 raised to minus 1? It will be minus 1 into x plus 1 raised to minus 2. Now let us see what happens in our next step. Okay, so we have got like this. Now I am going to integrate this further. What is exponential integration? E raised to x. It is e raised to x itself. Now after integrating, now what I am going to do is, I will multiply this minus 1 and minus 1 from this side, and it will be plus 1. Okay, so minus into minus is plus. Now try to bring this x plus 1 raised to minus 2 to the denominator. Okay, now if you may observe, the second term and the third term is same. In the third term, I have not yet applied integration by parts, but you are so lucky that these two terms have cancelled each other. Otherwise, you may have to apply integration by parts for that term as well. Now, what will be the final answer? This is your final answer. Now, let us move on to the next question. Evaluate this integral x plus 1 by root x. These are your options A, B, C, D, E. Okay. Now, consider the given integral. Now, one way of solving this integral is only through simplification. Now, you can split the numerators. Okay. Now, what I am going to do is I am going to try to reduce it to one of our standard functions. Here, the standard functions can become x raised to n. So, what we are going to do is bringing the denominators to the numerators. Okay, so you can see that denominator, when it is brought to the numerator, it is x raised to minus 1 by 2. Okay, now try to simplify that further. You may pause the video whenever you like. If you feel the process is going to be a lot tougher, you can pause the video and take your own time in solving each and every step. So after simplification, now this happens to be our standard form, isn't it? X raised to n. What is the integration of x raised to n? In our previous slide, we have to discuss that formula. It was x raised to n plus 1 by n plus 1. Okay. So here I have written x raised to half plus 1 by half plus 1 plus x raised to minus half plus 1 by minus half plus 1. After simplifying, so this will be your answer. Now let us move on to the next question. Evaluate this integral 2x plus sine 2x divided by 1 plus cos 2x, and these are your options. Now consider the given integral. One way of thinking how to solve the integral is try to remember all the identities you have studied earlier. So here we have studied sine 2 theta and cos 2 theta. What is sine 2 theta? It is 2 sine theta into cos theta, and cos 2 theta is 2 cos square theta minus 1. Now you are substitute these identities in your integral equation. So you will get 2 sin x cos x divided by 2 cos square x. Split the numerators. Okay, now after splitting, you may notice we have lots of common terms. Now you can cancel all the common terms. Cos x. Okay, after cancelling, what is 1 by cos x? Secant x. What is sin x by cos x? Tan x. So you can bring the denominators to the numerators. So you'll get x secant square x plus tan x. If our first integration was only secant square x, then it was a standard function. Then what will be the integration of secant square x? Tan x. And what is the integration of tan x? Log secant x. These are our standard functions, isn't it? But here, if you may notice, we have x along with secant square x. That means we may have to apply product rule, which is integration by parts. But if you look closely, there is a relation between x secant square x plus tan x. I will tell you exactly what it is. Now, differentiate x tan x using product rule. It is first function into differentiation of second function plus second function into differentiation of first function. Now what is that exactly? X secant square x plus tan x. See, I told you there was a relation between x secant square x plus tan x, which is nothing but the derivative of x tan x. So remember, after applying the product rule of x tan x, you will get x secant square x plus tan x. Now we are going to substitute this in our given integration I. So here we have I is equal to integral of x secant square x plus tan x. Substitute that by dx of x tan x, and since integration and differentiation are inverse process, so your answer will be x tan x plus c. Now let us move on to the next question. Question 5. Integral of 1 by sin x cos x dx is equal to. So these are your options. Okay. So consider the given integral. There is one more method of finding the answer for this integration. That is, we can make use of the formula sin theta cos theta, which is nothing but sin 2 theta divided by 2. And then you can simplify that further, but I found that method to be a lot lengthy, so I have considered this method in solving the answer. So here what I have done is I have replaced 1 in the numerator with the identity sin square x plus cos square x. You know it is 1. So replace 1 in the numerator by sin square x plus cos square x. So after replacing, splitting the terms, you may find a lot of common terms in the numerator and denominator. Simplify that as well. Okay. Now you will be reduced by sin x by cos x plus cos x by sin x, which is nothing but integral of tan x plus cot x, and these are your standard functions. So directly you can write down the answer. If you are not familiar with the formulas, you may pause the video and then go through the previous slides which I have discussed earlier. Now what is integral of tan x? Log of secant x or minus log of mod cos x. There are two formulas for integral of tan x. That is, you can write log of mod secant x or minus log of mod cos x. Both are same. Plus, what is the integration of cot x? Log of mod sin x. Now, this is not one of our options in the question. That means we may have to simplify that further. Now, make use of the rule log a minus log b, which is log of a by b. Now make use of this, so you will be getting log of mod sin x by cos x plus c, which is log of tan x plus c, and this will be your answer. Now let us move on to the next question. Evaluate this integral minus 1 to 2 4x square mod x dx is equal to 17, 16, 15, 14, 13. These are your answers, options. Now let us check which among these are your exact answer. Consider the given integral. So in this integral we have a special function called as modulus function. Now what is modulus function? Modulus function is nothing but if x is negative, your mod x will be minus x. If x is positive, your mod x will be plus x. Okay. So in our integration, if you look closely, the lower limit is minus 1 and the upper limit is plus 2. So that means our integration is between negative interval and positive interval. So what we have to do is we have to split the integrations into 2. So negative, that means from minus 1 to 0, and positive, that means from 0 to 2. Now write down the functions. Now you know exactly what is mod x in the negative interval. It is minus x. And what is mod x in the positive interval? It is plus x. Now try to replace with these functions and then simplify that further. So you will get minus 4x cube in the integral minus 1 to 0 plus integral 0 to 2 4x cube. Now you can integrate that because it is a standard function. What is the integration of x raised to n? X raised to n plus 1 by n plus 1. Now after applying the limits, and then simplifying further, you will get the answer as 17. Now, consider the next question. Evaluate the integral x plus 1 the whole square divided by x into x square plus 1 dx. And here are your options. Okay, now consider the given integral. I told you always try to compare the numerator and denominator. If not, try to remember all the identities you have studied. Now, you have already studied an identity, isn't it? A plus b whole square in the numerator. Apply that identity. So, you will get x square plus 1 plus 2x. Now, compare the numerator and denominator. You have the denominator as x square plus 1. So, group the terms x square plus 1 in your numerator. So, after grouping, you can split the integrations into 2, and then after splitting, you can cancel the common terms. Okay, now you will be left out with only 1 by x plus 2 divided by x square plus 1, which are nothing but standard functions. What is the integration of 1 by x? It is log of mod x plus 2 into, what is the integration of 1 by x square plus 1? It is tan inverse of x. So, you can directly write down the answer. Now, next question. Here, if minus 1 to 4 f of x dx is 4 and integral of 2 to 4 3 minus f of x dx is 7, evaluate the integral minus 1 to 2 f of x dx. Here, without knowing the function, we are actually finding out the integral from minus 1 to 2 of f of x dx. So, consider the first condition. From the first condition, we are not going to arrive at any conclusion, isn't it? Because we don't know what exactly is the function and how can we integrate this. But look at the second condition. So in this second condition, it makes some sense because we can solve the first integration, that is integral from 2 to 4 3 dx. We can solve that and then we'll get some result from that condition at least. Now let us go through the options. Okay, 1 2 3 4 5, these are your options. Now I told you, let us begin with second condition. Okay, now you can split the LHS into 2, that is first term and second term. Okay, now you can integrate the first term, which is 3 into x. Integral of 3 is 3 into x. Apply the limits 2 to 4. There is no change in the second term as it is, and also 7 as it is. There is nothing changed in these terms. We are only solving the first term. Okay, after applying the limits and then simplifying that further, you'll be getting a new result, that is integral from 2 to 4 f of x dx is minus 1. Call that as equation number 1. Now we have not yet used the first condition. So this is your first condition. Now how can we use our new result in this first condition? You may notice in our new result, equation 1, we have the lower limit as 2. So upper limit as 4. So what we do is, in our first condition, we are going to split the integration into 2. That is from minus 1 to 2 f of x dx plus 2 to 4 f of x dx. Now what is integral from 2 to 4 f of x dx? It is minus 1, isn't it? Now here, what is the integral of 2 to 4 f of x dx? Substitute it as minus 1. After substituting that and then solving further, so we got our answer. This was our question. They have asked what is the integration of minus 1 to 2 f of x dx, and we got the answer as 5. Now let us move on to the next question. If integral f of x cos x dx is 1 by 2 f of x whole square plus c, then find the value of f of 5 by 2. See, here also we don't know the function, but we are finding the value of f at 5 by 2. These are your options. Now consider the given equation. Now, since we have only one equation and then we don't have any second condition, so one way of removing this integration is by differentiating the equation on both sides. So after differentiating, okay, since the differential and integral are inverse process, okay, so in left hand side we'll be left out with only f of x cos x. And what about the right hand side? What is the differentiation of 1 by 2 f of x whole square? It is 1 by 2 into 1 by 2 into, what is the differentiation of f of x whole square? 2 into f of x into, and f of x you have to differentiate again. So it is f dash of x. Now cancel the common terms. So 2 in the numerator and 2 in the denominator. Now after comparing both left hand side and right hand side, we will get f dash of x as cos x. Now since this is the derivative of f, we have to integrate this further to get our function f of x. So integral of cos x is sin x plus c. So you got f of x. We need f of pi by 2. So put x as pi by 2. So f of pi by 2 is equal to sine of pi by 2 plus c. What is the answer of sine of 90 degree? It is 1. So 1 plus c. This will be your answer. Thank you students. I hope you found this presentation very useful, and you keep continuing watching my rest of the videos which I will post later. But in my other videos I may have not given enough time for the question in each slide. You can pause the video and then go through the question in each slide, because I found to make use of much time solving the answers. Thank you students once again.